Welcome to this second video on the Foundry Gauntlet Revision 1 for Hardship. So the Foundry Gauntlet, the Gauntlet is a competitive event with exclusive and new stage for 4 weeks, once per week. So today, like last time, I will just do a naive solution for the week 1. But first I will just explain a little bit the scoring system and how it works. So let's do this. First, to join the website, to reach for the website is quite easy. You can just find for all leaderboard buttons. So if you go on the Gauntlet, there is quite a few of them. And when you click on it, it will bring you on the website. From the website you can use the Gauntlet, just hardship.io and Gauntlet, and just go to the active Gauntlet. So this week is the week 1. We started the DLatch Cell with some features with output enable and root call select. So the Gauntlet is a 4-week event. You might say maybe you missed the first week, but the first week was a warm-up week. You can still participate and have the full score. So yeah, each week you need to submit solution for your for the stage, and you have until Saturday 6 p.m. UTC to submit your submission, and then the system will choose the best one and try to rank you against all other players. Those sections are quite useful. You will have all the videos about the Gauntlet here, so if you want to follow along with the next video, you will find that here. You have the reveals. Each week will reveal the best design. It's quite useful because it's an incremental challenge. So the Gauntlet, for each week, you use the previous week to build upon it. And if you do something that is really inefficient, like week 0, it will carry next week. So you have the choice to take the best and winning solution from 1 week to use it for your next week, or you just can carry your design all along. You have the rules. Everything I will cover here is just a subset of what it's described here. It's all you need to know. If there is a question, reach out for myself, Eloth, on Discord. I'm really active over there. And then you have the leaderboard itself. So you have multiple leaderboards. I will cover them quickly. So first, the most important Gauntlet leaderboard is the event leaderboard. So it's the one you need to look for to determine who will win the entire event. So there is a system of score, and the one who has the best score wins. It's over 300 points. The week 0 didn't count on this leaderboard, so it's for that reason that this week 1 that just started is the only one contributing to this Gauntlet leaderboard. Week 0 doesn't participate in that. And then you have the week leaderboard. This is the leaderboard specifically for each challenge. You can change it, and let's change to week 0. Oh no, let's go back to week 1. I will explain it here. So each player can submit as many submissions as they want, but the system will just keep one, the best that is judged by the system, to be the one that is contributing to the week leaderboard, and for the Gauntlet entire event. So for example, here Tyrnid, the best solution that was selected by the system is this one with 1,113 ticks, 642 blocks, and etc. for the volume and range. But Tyrnid has submitted many other solutions with various metric scores. So how does the system select which one is the best? Because our chip is open-ended, it's quite hard to find the best solution without AD-dot, because you need to optimize multiple objectives and sometimes they are contradictory. So it's kind of a mix of all those metrics, and it's the use of the next 4 leaderboards. So you have 1 leaderboard for each metric. So for example, we have the ticks range, which is a leaderboard only based on this one metrics, the ticks. So this is the speed of your solution. And this leaderboard is quite simple. It takes all submissions from all players and it takes the best ticks from that player and it ranks those solutions against each other. And what that helps us with, it's determining the range. So the best solution will determine the lower range, and the special player subprocess will determine the worst range, the slowest one. And you have that for all metrics, blocks, volume, and transistor. So with those range, we can now determine what are normalized score for each submission. We rank them on to 0 to 100, and with that we can just add them together and have a basic score on 400. But we don't want to have equal participation of all metrics, so you have like weight applied. So ticks will count for 40% of the end score, block will count for 20, as well as volume and transistor 20 as well. So at the end you have a maximum score of 100, 40 from the tick, 20 for the block, and volume and transistor. So that's cover everything. I think I don't forget anything really important. All the details are explained here. It's really the source of the reference for all these gauntlets, and you can follow those scores live. It's updated every 5 minutes by the server. Submission can be ingested by the system to maybe 30 seconds to a minute. So sometimes you can miss the train from one update, but you will be there the next one. And there you go. I covered the basics for the scoring system. Now let's move on to the naive solution for this week 1, the Gated DLatch Cell. So let's go into the game. And so you have this requirement. I hope it explains everything. If you have commentary on that, I will gladly listen to them. It's really important for me, your feedback. It's what's making the game. But I don't really need that. I will let you read if you need this. You have the schematic. You are maybe quite used to them if you are already playing a chip. I will leave it here because I will use it as naive solution. Use the schematic, but like I said before, those schematics are really scalar and quite simple. You can go way more efficient by ignoring those schematics. It will be harder, but there is other ways to fulfill the stage requirement. And then you have a new schematic, which is not really a schematic, but an explainer for the truth table. So if you take the truth table, it's quite big and it can be intimidating. So I just added this little addition that splits the truth table into phases. So the first 4 are the phase 1, which is the basic action of writing a cell and then testing the cell those as the value, and then we clear all the flags for the next phase. The next phase, we are retrying the same operation, so writing a value, which this one is 1. And then after, you have various phases to test other conditions, like you can't read without row and call select, so they must be all two, they must be 1. And so yes, phase 4 is exactly the same. And these 3 outputs on the right, they always match what the corresponding input is. It will be used next week and the week after that, because there is an idea with that stage, and I want to force a little design on you. So this is a requirement. You need to be able to push the value through the right. So it won't be too hard, I think, but it can be hard to optimize blocks because you have to route the signal on the right side of the die. So let's go with that. We'll start with our naive solution. And because I don't want to be too slow with that, I will just take the DLatch from the winner of this last week. So I can just go there and I can click and copy image link. So those are HT drives. They are images, like you can see, but they carry metadata that our chip can read, and in them there is, like, for example, this one is a blueprint. So if I do that, I can just click import and have that. So you can use the option from there, what I just did. It won't create a blueprint and all, but if you do that from the library screen and tab HC drives, it will install for good the blueprint. And so you could use then like from here, like would be cell, or I think I call that winner. Yes, so we got it. And I will take this one because when you install with the blueprint, it will keep those labels that help us know where we need to plug stuff around. So yeah, let's use that one instead. So I will just place those gates and the DLatch and the tree state, which is a requirement that you can do from the bonus screen. There is this stage you can do, it's transceiver. Let's try this from scratch. So I want this, a DLatch, I want a 3 state. Should work. And I want 3 AND gates. So let's just take roughly the same shape so I can do that quickly. It will be quite ugly, but we are not looking for something efficient or fast. We just want to make the naive solution the fastest possible. So we need this gate, AND gate, to be our row and column select. So we have this like that. You want them to have the right from the below one, so this the bottom, and so the out of this gate comes here, and then the top AND gate is this, so it takes our row call select values and the enable flag. So it's all we need for those 3 and I will just connect them. So it's done. So I think I like to do is just having like nice line everywhere, but maybe it will be more efficient to go there. Up. I can cut that. This. Oh, I have to cut here. So all with Alt button down, and you can do that. Okay. Okay, I could do better, but will be enough, I guess. Let's stop there, because this is what our ship is about. At least for part of it is you can optimize a lot more. So I won't go into that rabbit hole here. So we have our 2 exits from those AND gates, and then we need to carry the value of byte in. We'll take it from up there. We'll route the in value. You know what? We'll do that the other way around. Put that at the bottom. And then we'll do that here. So our in is connected, and we'll remove that. And then the end load, so it will be right. Sometimes names are not coherent. I guess my bad. I can reflect the role as well, because in real life a lot of stuff that does the same thing doesn't use the same names. So right need to go there. Yes. So we have our right. Remove, and this is not the proper way. So we can take it like that, but I like to show some tips. So for example, this can cut with Ctrl X, Ctrl V, and then we can flip like we did last week. And this time around, I will just flip it the other way. I will try to align the input like they were before, and that should be good. Okay, what's there? Oh my god, these lines, the power line rails are giving me PTSD. So we wanted to have the enable to the tree state buffer, so it's there. So this is one of those blueprints where I didn't put the labels on it, so I kind of forgot what is doing, which pin is doing what. So I can give you a little trick. So we can use power lines to get some ground, and so 0 and 1, low and high. You can run the simulation, and so we know blueprints are all stages are the same. Input are on the left and output are on the right. So this is the value that we want to read. But here there is a pin which is the value we need to go through the tree state or not, and the other is the pin that command the enable pin from this tree state. So you can use input blocks. So those blocks are special blocks, and you can recognize their symbol because they are the same from the input driven by the truth table. And we can just add probes, little probes, so just click on it. Here I just put 2, so let's just like 1. You can keep the default number, you just click on it, enter, and it will create a probe real quick. So now we have value we can command real quick. Sometimes you want to have the third state, so you can use the maximize button and you will have some option for that label. So if I stick to the screen, it will just stay in place. You can use the second button to allow neutral, which is kind of really handy because now we can set the input to neutral. You can put a breakpoint, so if we find a value that is 1 at this, it will stop. So this is a label. When you put a label onto an input block, you can edit the value of that block. But you can add a label onto something else, like this, and you won't have the button, but you still have the breakpoint. So you can stop the simulation when this value is reached to that specific point. So it's really handy if you want to avoid a long step-by-step journey when you have like a little problem. Edit will just allow you to edit the probe or remove. So this was a quick explanation of probes. I won't do the same because I just want to determine what's the pin that drive the output and what's the input to the output and what's drive the enable pin. So it seems this one is the input and the value we want to hide, and this is and I need to remove the breakpoint because it's kind of annoying. Stop at error, don't stop. So we can see here if it's 0. Yeah, so if it's 0, the value doesn't go through. Let me remove the neutral because we shouldn't use the neutral value for the tree state. When it's 1, the value goes through, regardless of what's the input. and when we switch back to 0, it switched back to neutral, so nothing goes out. So we have our 2 pin, so our enable is this one, so we know this is the enable because it comes from here, the AND gate, which is this one, and it must be enabled, and the row call select must be true as well. So I guess we can try. So if we are enabled and if we are selected by the row and the column, this should be enabled. Yes, so I did that in reverse. It should be the other way around. This is the value. So we just do that. And now, regardless of the value, we know it will be driven out by this tree state. So let's go with the out of our previous DLatch. So this is the DLatch from the last week. And we'll clean things a bit. And then we are completely set up. We just need to wire up this DLatch. Let's plug that to the power lines. And then we should be good. Okay, so now we have to take care of the output pin. So we want... Oh wow, I'm about to do something real ugly. Okay, let's do that instead. You can use the select and delete. I like to do that. So we need the enable signal. Let's do that. I will lazily put that here, so the select is good. Now we need the row. So the row is here. I will just invert those two, so you can use this button to move your inputs up, and I will be lazy one more up. Yes, we'll go there, and then we'll bring our row select here, and we still need to take care of right, and right will be more convenient at the bottom, and let's do just that. Okay, perfect. I mean, perfect. It's a big word. So now it's the moment of truth. Will that run first try? Let's find out. And no, it doesn't run. So what is wrong here? So our enable is 0 and we want 0, 1 and 1, and our output should be 0 and it's now neutral. So, and indeed we did a little mistake here. The byte in should go and short circuit all this assembly. So we need to drive the byte in from there to there, and I'll just do something simple. And we heard the little tick, means that the condition for that stage is validate. For that step, sorry. So let's try again. Okay, it goes well. Ooh. Let's say it was first try. So this was the naive submission. Not really naive, because naive is based on his own design from previous weeks. So it's won't be like, for example, I'm playing with my player, so it's healers, so it will maybe be a tight bit better. But yeah, is there something else we can do, or should I conclude the video here? I think it's already quite a long video, so I might just stop there. So yeah, it was all for the week 2, which is the second week, not the week 2, but second week, so it was week 1. And if we wait a little bit longer, maybe you can go see yourself. This score will be updated to my new high-performing solutions. So I will stop that here. Thank you a lot for watching this video, and see you next week for the week 2 stage, with a little bit of tips and maybe some other explanation. If you have any question, don't hesitate to leave the comments below, and or reach for myself from even other player on Discord. And yeah, have a good one, and see you on the leaderboard.